Hello all, good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Matrices and Calculus, and we are on to the topic of eigenvalues and eigenvectors. In the previous video, we have seen some problems regarding the characteristic equation before moving on to eigenvalues and eigenvectors. In this video, we will have another approach on the particular problem which we have learned in the previous video. The given matrix is 1, minus 3, 4 and 1. This is the given matrix. We are going to use the formula to find the characteristic equation of a 2 cross 2 matrix to find the characteristic equation of the given matrix A. So for a 2 cross 2 matrix, we will have the characteristic equation to be lambda square minus s1 lambda plus s2 is equal to 0, where s1 is the sum of the diagonal and s2 is equal to the determinant of the given matrix A. So this is how we have learnt in the formula. What we are going to do now is, we are going to find the sum of the diagonal elements. Sum of the diagonal means the given matrix is 1, minus 3, 4 and 1. We are going to add the diagonal elements, which is 1 plus 1, which is equal to 2. And later we are going to find the determinant of the given matrix. Determinant of A is cross multiplying and putting a minus in between. So that is what we have done here. So the value of determinant S2 is equal to 30. Now the characteristic equation, what will be our characteristic equation? We will just merely substitute the values of S1 and S2 in the particular equation here. So lambda square minus 2 lambda plus 13, which is equal to 0. This is what we have done. This is what we have got through the direct method also. The same will be applicable for all the other methods as well. So now we will move on to the third problem, and we have done it in the direct method. To find the characteristic equation of the given matrix 1, 2, minus 3 and 4, we will just fix the given matrix to be A. A is equal to 1, 2, minus 3 and 4. The characteristic equation is given by determinant of A minus lambda I is equal to 0. In the first step, we will be finding the lambda into I. The second step, we will be finding A minus lambda into I. In the third step, we will be finding determinant of A minus lambda I is equal to this thing. And what we'll do for the determinant calculation is, we will just cross multiply and putting a minus in between will give you the determinant value. What we have done here, 1 minus lambda into 4 minus lambda, 2 into minus 3 we have done here, and we have done a minus symbol here, which means we are just substituting and manipulating it in the known formats, or this is an algebraic expression. So we will have the characteristic equation to be lambda square minus 5 lambda plus 10 is equal to 0. And also in the second method, what we will do, we will just take the formula which is on hand, which is lambda square minus s1 lambda plus s2 is equal to 0, where s1 is the sum of the main diagonal, which is 1 plus 4, which is equal to 5, and s2 is equal to the determinant of the given value, which is 1, 2, minus 3 and 4. What we will do for this thing, we will be just cross multiplying and we will put a minus in between. So this is what we have got here. 1 into 4 is 4, minus 3 into 2 is minus 6, and we have got a minus in between, therefore the value is 10. And the characteristic equation is lambda square minus 5 lambda plus 10 is equal to 0. So this is how we get the characteristic equation using the direct method and the formula method. Now we will have some of the properties of eigenvalues. First of all, we will note what are the eigenvalues. Eigenvalues are nothing but the roots corresponding to the characteristic equation. Determinant of A minus lambda I is equal to 0 is called the eigenvalues of the matrix. What do you mean by roots? Roots are nothing but the values of the lambda, constant lambda. Values of lambda in the particular equation is known as the roots. Whenever we equate an equation to 0, that equation will correspond to the unknown values. The power of the equation will be the number of values for the given unknown constant. So here unknown value, here lambda is unknown. Therefore, those lambda which corresponding to the characteristic equation are called the roots of the characteristic equation, and those values are called the eigenvalues of the given matrix A. So the eigen values can be found using the characteristic equation, and that is why we have learnt it earlier. These eigenvalues form the base for the matrices and calculus here. The roots corresponding to the characteristic equation determinant of A minus lambda I is equal to 0 is called the eigenvalues of the given matrix A. In the next video, we will see the properties of eigenvalues and some of the problems related to eigenvalues and eigenvectors. Thank you.